Welcome back, dear students. So today we'll be continuing with our exercise 17a. Let's start with question number 5, which says, in the following figure, that is this figure, AD is a straight line. So you see AD is a straight line. OP is perpendicular to AB. Okay, so OP is perpendicular to AB. And O is the center of both the circles. So O is the center for both inner circle and the outer circle. If OA is equals to 34 centimeter, OB is equals to 20 centimeter, and OP is equals to 16 centimeter, find the length of AB. Right. So let's try to understand what is being said here. Okay. So OA is given. So from here to here, that's OA is the radius of outer circle. Remember, OB is given to be 20, so OB is this, that is, it is the radius of inner circle. OB is the radius of inner circle, and OP, that is this height, is also given. Okay, so this height is also given, so you need to find what is the length of AB. Okay, so what am I going to do here is, so in order to find AB, what will I find is, first I'll find AP. Okay, forget about outer circle, forget inner circle. So you have this kind of triangle, right angle triangle. So you know what is OA and what is OP. So find what is AB, right? And now after that, forget about outer circle. So in the inner circle, we know OB and OP. So we'll find BP. So from AP, we will subtract BP. You'll get the value of AB, and that's what we need to find. Okay, so that's why, see, for the inner circle, BC is a chord, right? So BC becomes a chord for inner circle, and OP is perpendicular to BC, means what? If it is perpendicular, then BP will be equals to PC, right? So we have BC gets bisected, so that's why you have BP equals to PC. Okay, simple. So we have, by Pythagoras theorem for inner circle, okay, by Pythagoras theorem, we have OB square is equals to OP square plus BP square. Now let's put the value of the known things. So we don't know what is BP square. So we have BP square equals to OB square, which is 20 square, minus, when it goes over there, it becomes minus. So OP is 16. I'm sorry, yeah, OP is 16, yes. So OP is 16, so it becomes 16 square. So 20 square minus 16 square. So when you simplify it, you get 144. So BP square is 144. So that's why BP turns out to be square root of 144, which is 12 centimeter. So we got BP. Now similarly, for outer circle, AD becomes the chord and OP is perpendicular to AD. So that's why AP will be equals to PD. So that's why we have AP equals to PD. And again, by using Pythagoras theorem, we have for outer circle, remember, OA square is equals to OP square plus AP square. So from here also we'll calculate AP. So AP turns out to be, first bring this OP out here. So you get OA square minus OP square. OA is 34 square minus OP is 16. So it turns out to be, when you simplify it, you get this to be 900. Now AP square is 900, means you get AP is root over 900, which is 30 centimeter. Okay, so we got AP and we got BP. So that's why your AB, as I told you, AB will be AP minus BP. So AP is 30 and minus we have BP is 12 centimeter, which turns out to be 18 centimeter. So that's why the length of AB, that is your answer, turns out to be 18 centimeter. Pause the video and note down your solution. We have another question which says, in a circle of radius 17 centimeter, two parallel chords of length 30 centimeter and 16 centimeter are drawn. Okay, find the distance between the chords if the chords are, number 1, on the opposite sides of the center, number 2, on the same sides of a circle. So what is the meaning of this? Let's try to understand using this diagram. Okay, so this is a diagram for, number 1, and this is the diagram for case 2. Okay, so there are two parallel chords inside the circle. Okay, so you see AB and CD are parallel, but in this case, number 1, we have center is O. So AB and CD, they lies to the opposite sides of the center, right? So they are on the opposite sides of center. Now in this case, AB and CD, they are also parallel, but they are on the same side of the center. See, we have got center here and we have got on the same side of the center. Okay, so these are the two different cases, but the rest of the work is same. Okay, now it is given that radius of the circle is 17 centimeter. Okay, so notation is same. Okay, so from O, if you drop a perpendicular on AB, you are denoting that perpendicular by OE. Similarly, if you see here, OE is perpendicular to AB. Similarly, here OF is perpendicular to CD. In this diagram also, OF is perpendicular to CD. Okay, so the calculations that we are going to do are going to be same for these two. So that's why I'll be showing only one calculation. Okay, so see here carefully, OA and OC. Okay, so here also OA and OC represents the radius. Okay, so O being the center of the circle and AB and CD be two parallel chords. As I told you, AB and CD are parallel chords of length 30 centimeter and 16 centimeter respectively. It is given. Okay, so that means AB is 30 and CD is 16 centimeter in both the cases, remember. Okay, now drop OE and OF perpendicular on AB and CD from center O. I have already talked about this. OE is perpendicular to AB and OF is perpendicular to CD. That's what this sentence says. Okay, now you know OE bisects, this perpendicular bisects the chord. So that's why AE becomes equals to EB. So AE becomes, see, if you look at this diagram, so I'm interested only in AE. So AE becomes half of AB. AB is 30, so that's why AE will be equals to 15 centimeter. And similarly, OF is perpendicular to CD, so that's why CF and FD both will be half of CD. So that's why CF will be equals to half of 16. Okay, because CD is 16, right? So that's why CF will be just half of 16, which is exactly 8 centimeter. All right, so we got AE and CF for both the diagrams, remember. Okay, so that's why if you look at this triangle OAE, here hypotenuse is OA, so that's why if you apply Pythagoras theorem, it becomes OA square equals to OA square plus AE square. So we know what is OA, it is the radius. We know AE. Okay, so do we know what is OE? We don't know, so we'll calculate OE from here. It turns out to be 8 centimeter. Similarly, from this triangle, what we are going to do is we'll find what is OF. Okay, so OF turns out to be 15 centimeter. It's very simple, right? Now there are two cases being asked, so we found OE and OF for both the cases. Now for the first case, you have to find the distance between the chords, right? For the first case, the distance between the chords, that is, it becomes EF, isn't it? EF is the distance between the chords. So if it is EF, then EF can be written as OE plus OF, isn't it? So we have OE. How much you found? OE is 8. And what is OF? OF is 15. So 8 plus 15 turns out to be 23 centimeter. Okay, so this is the case where the chords lies exactly opposite sides of the center, right? But in this case, in number 2, if you want to find the distance between the chords, that is EF, what you will do is from OE, okay, from OF, you will remove OE. Okay, so we have distance between chords, EF becomes OF. From OF you remove, that is, you subtract OE. So OF is 15 minus you have OE is 8. So 15 minus 8 turns out to be 7 centimeter. So that's why your answers are 23 centimeter and 7 centimeter for this case. Okay, so you may pause the video and note down the solution. So I've got one homework for you. So read the question carefully. This is similar to earlier question number 6. Try it and get back to me. So with this, we close for the day. Thank you very much.